Hi, I'm Pat Kelly. All right, in this problem, they give us the probability distribution shown here, and we're asked to find the mean and the median. So for the mean, mu equals, it'll be our integral from 0 to 1/2 x times f of x, 4 parentheses 1 minus 2x dx in this case. It's following the formula for mean. I'll evaluate this integral. First thing I'd probably do is pull out that constant factor of 4. Integral still from 0 to 1/2. And I think I'll push the x through. So we're looking at this integrand. That's a definite integral. We'll just go ahead and find the antiderivative. 4 x squared over 2 minus 2x cubed over 3. And we're evaluating from 0 to 1/2 equals 4. Putting in the 1/2, we're going to get 1/4 over 2. Putting in the 1/2, we're going to get 1/8, but multiplied by 2, that's 1/4 over 3. It's all still multiplied by 4. I put in the lower limit of 0, but that's going to be 0 and 0 again, so we're subtracting 0. Okay, a little bit of arithmetic, and what I would advise right here is notice each of the numerators is 1/4. It's just a coincidence. It's convenient for us, though, because I'm multiplying by 4, so I'm going to go ahead and push the 4 in right now, which actually just makes it 1/2 minus 1/3. A little easier on the arithmetic then. Common denominator of 6, and we'll get a final answer there of 1/6. That's our mean. Okay, in the second half of the problem, it's going to be a little bit more work, but they also ask us to find the median. So to find the median, what we have to know is that the median is that halfway mark of the curve, where half of the data is. So I'd have to start by thinking of the integral of this original function. And what we've done before is with your limits of integration, you're asking for the area under the curve. In this case, we're going to go from 0 to start, but we're going to end at an unknown point. That's going to be our median. So we know where to start. We're trying to find out where to end, and we want that, we're going to set it equal to half the curve. So that's our understanding of median, is that the area from 0 to that value of the median would give us the halfway mark on the curve. Okay, so the real challenge is going to be to find that value of m. So I'll go ahead and start by looking at my integral, trying to evaluate that. Pull the 4 out, integral from 0 to m. Okay, now as I do this integral, 1 minus 2x on the inside dx. I'll just do my antiderivative, x minus x squared from 0 to m. You notice that unknown value of m that we're trying to solve for carries along. It was an upper limit of integration. It's still an upper limit of integration. I'll go ahead and plug it in. So our result here is going to have that m. That's what we're trying to solve for. But we still have that go-to over here that we know it's supposed to end up equaling 0.5. That'll give us an equation in m that we can actually solve then for m. We'll see that in a minute. So now we'll just go ahead and evaluate using our fundamental theorem of calculus for m minus m squared. Put in that lower limit of 0, but again that subtracts out to 0. And that's our result for the integral, but it has that m in it. That's what we need to solve for. So I take this expression, go ahead and push the 4 through. I don't need the 0. And that's what I need to set equal to 0.5. That's the equation I mentioned that we're going to solve now for m. Solving that for m then gives us our median. Okay? So let me come up here and solve for m from this equation, 4m minus 4m squared equals 0.5. It's a quadratic equation, but it might take a little bit of work. First thing I might do is clean it up a little bit and get the leading coefficient to be positive, which means this is going to be negative, and bring everything over onto one side. So we would get that Next thing I would do, and this is preference, but I don't really like the 0.5, so if I multiply everything through by 2, I'm going to get 8m squared minus 8m plus 1 equals 0. Looks to be a little bit more manageable. It's a quadratic, and I can think about it for a little bit and try to factor it, but it doesn't factor. So I'm going to have to resort to the quadratic formula. The quadratic formula, you know, is the opposite of b plus or minus the square root of b squared minus 4ac, minus 4 times 832 times that, 1, get that, all divided by 2a, get 16. Always comes in handy, the quadratic formula. Now let me try to clean that up a little bit. Under that square root, it's just the square root of 32. But even that, I'll try to clean up a little bit. It's the 32 I can factor a little bit. 16 times 2, so I can pull a 4 out. Square root of 2 over 16. And that's convenient for me because now I can factor out a 4 and make this even a little bit cleaner. If I factor out a 4, I'll get 2 plus or minus square root of 2 over 4. So what I'm finding in solving the quadratic equation, the quadratic formula, solving the quadratic equation using the quadratic formula is that I get these two results for m. Two different values. So let me go ahead and approximate each one with a calculator just to see what they look like. For this one, 2 minus square root of 2, 0.15, and also 0.85. Okay, so we'll resort to the calculator there for those approximate values. We still have to try to address what's going on with this m that we were originally trying to solve for. We have two different answers. This m is supposed to be the median, which will mark halfway through the curve. We have two different answers, but notice one of them, the 0.85, is outside of our interval. Okay, so that's not the one that we want. Our m of 0.15 is inside the interval from 0 to 1/2, and furthermore from 0 to that 0.15 would give us half of the curve. It's the median. Okay, so we end up with the mean of 1/6 and the median of 0.15. Hopefully that helps. Thanks.